Yes, good evening. Mahaganadhipataye Namaha. Good evening, Vaishnavi Kesani. Everyone open your textbooks, go to 10.1 exercise. First exercise. Exercise 1. How many tangents can a circle have? How many tangents can a circle have? Anyone? Infinity. Very good. Very good. As I told you in the morning, at every point on the circle we can draw a tangent. At every point on a circle we can draw a tangent. So since the circle is having infinite number of points on it, so we can draw infinite number of tangents to a circle. So answer infinite. Second question. A tangent to a circle intersects it in dash points. A tangent to a circle intersects it at how many points? 1 point. Very good. 1 point is a correct answer. Next one. Second question. A line intersecting a circle in 2 points is called. A line intersecting a circle at 2 points is called secant of the circle. Very good. Secant of the circle. Good. Right. A circle can have dash parallel tangents at most. A circle can have dash parallel tangents at most. 2. 2 correct. Why? See, if you draw the diameter in a circle, try to draw the diameter. Circle, center, diameter. A, B. So, this is tangent L at A and this is tangent L at M at B. O is the center of the circle. We know that OA is perpendicular to the tangent at L. At A, L is tangent to the circle. L is tangent to the circle at A. That means OA perpendicular to L. M is tangent to the circle at B. That means OB perpendicular to M. Since these two are perpendicular, OA perpendicular to L and OB perpendicular to M, if interior angles on the same side of the transversal are supplementary, then the lines are parallel. Okay, na? So for every tangent we can draw, at most we can draw 2 parallel lines, 2 parallel tangents. That's all. 2 parallel tangents. Question number 4. The common point of a tangent to the circle and the circle is called, what we call the common point, right? What we call this common point? Anyone? Point of contact. Very good. Point of contact. Good. Now, third question. Tangent PQ at a point P of the circle of radius 5 centimeters meets a line through center O at a point Q so that OQ is 12 centimeters. Find the length of PQ. What is that? There is a circle with center O and PQ is a tangent at P. PQ is a tangent at P. Radius is given 5 centimeters. Radius is given 5 centimeters. OQ given 12 centimeters. OQ given 12 centimeters. And we need to find out the length of PQ. How to do it? We need to find out the length of PQ. How to do it? Anyone? Pythagoras theorem. Pythagoras theorem must contain a right angle, na? In this triangle POQ, where is the right angle? OP perpendicular to QP. Good. Radius is perpendicular to the tangent at their point of contact. Radius is perpendicular to the tangent at their point of contact. That means angle P 90 degrees. So apply Pythagoras theorem. OQ square is equal to OP square plus PQ square. 12 square is equal to 5 square plus PQ square. 144 minus 25. How much is PQ? How much is PQ, children? Very good. Root over 119. Good. Root over 119. Option D. Now, fourth question is not there in the syllabus. Is it there in the textbook? Draw a circle and two lines parallel to the given line such that one is a tangent, the other one is the secant of the circle. Is that question is there in your textbook, new book? Is it there in the new book, children? Okay. Actually, that is construction. We'll see it in the class tomorrow. Now go to second exercise. Exercise 2. 10.2. Exercise 10.2, first question. From a point Q, the length of the tangent to a circle is 24. And the distance Q from the center is 25. Find the radius of circle. A circle with center O. Okay. Now, there is a point Q. From this point, length of the tangent. Length of the tangent is given how much? 24 centimeters. And the distance between Q and the center is 25 centimeters. We need to find out the radius. How to do that? Divya says 7 centimeters. Even Vanshika 7 centimeters. using Pythagoras theorem. OP is radius, QP is tangent at P, QP is tangent at P, OP is radius. We need to find out radius. Pythagoras theorem, R square plus 24 square is equal to 25 square. R square plus 24 square is equal to 25 square. Then R square will be 625 minus 576, which is 49. R will be root over 49, 7 centimeters. So radius of the circle is 7 centimeters. Okay na? Now second question. Second question. There is a figure given to us. A circle with center O, TP, TP, TQ are tangents, and this angle is given as 110 degrees. We need to find out this angle. Yeah. How much it is? We need to find out angle PTQ. Bashita says 70 degrees. Even Sohili 70. Aniket 70. Who is Suri Divya? So everyone says 70 degrees only. Lisa, Hasini, Tanush. But no one saying the reasons. What is the reason? How can you say it is 70 degrees? Angle O plus angle P plus angle T plus angle Q, 360 degrees. Good. So this angle 90, 90. So 90 plus 110, 200, 290. Then automatically this will be 70. Why 70? TPOQ is a quadrilateral. TPOQ is a quadrilateral. Okay. And we know sum of interior angles of a quadrilateral is 360 degrees. We know 3 angles. And it is easy to find out the 4th angle. Okay, na? We know angle P, we know angle Q, and we know angle O. So 90 plus 90, 180 plus 110, 290. 290 remaining angle is 70 degrees. Okay, na? Good. Next question. Question number 3. Tangents PA, PB are drawn from a point P to the circle with center O are inclined to each other at an angle of 80 degrees. What is angle POA? POA. So what is the question? Try to understand the question. There is a point P and there is a circle with center O. PA is one tangent, PB is another tangent. Okay. So angle between the tangents is given 80 degrees. Angle between the tangents is given 80 degrees. And he is asking to find out POA. POA means this one. What is angle POA, children, and what is the reason? Morning only we have discussed one theorem. Vanshika says 50 degrees. Vaishnavi 40 anton. You are right. Angle OPA 40. Morning theorem lo em cheppukunnam? What we have seen in the morning? This OP bisects the angle between the tangents 40. OP bisects angle between the tangent. I told you na, 40 degrees. Then we know radius is perpendicular to the tangent at their point of contact. Radius is perpendicular to the tangent at their point of contact. Now in triangle PAO, angle A plus angle APO plus angle POA is 180. So angle POA is 50 degrees. This is 90 plus APO 40 plus POA 180. So POA will be 180 minus 130. 180 minus 130. So here what is the key point? What is the key point in this problem, children? That you feel that if we don't know that point, we cannot solve this problem. Once again I am asking, what is the key point in this problem? So that if we don't know that, we cannot do this problem. Yes, OP bisects angle P into two equal angles. Very good. Not only angle P, it bisects angle AOB also. OP bisects angle P as well as angle AOB also. It divides angle between the tangents as well as angle between the radii. Now, question number 4. Question number 4. Prove that tangents drawn at the ends of diameter of a circle are parallel. There is a circle with center O. AOB is the diameter and two tangents are drawn. Two tangents are drawn. L is one tangent and M is another tangent. L is a tangent to the circle at A and M is the tangent to the circle at B. We need to prove that what is given? What is given? AOB diameter and L and M are two tangents at the end points of diameter. L and M are two tangents at the end point of diameter AOB. What is required to prove? L parallel to M. What is required to prove? L parallel to M. Prove that tangents drawn at the end point of diameters are parallel. Means we need to prove L parallel to M. For that, it is enough to prove take one more point here. Let it be C and D. Let it be. Angle AOC, angle OAC plus angle OBD is 180. If you prove this, consider one more point on L, that is C, and one more point on M, that is D. If we prove angle OAC plus angle OBD is 180, then automatically L parallel to M. Okay, na? Is that understood, children? Yeah. Now, proof. OA perpendicular to L at A. What is the reason? OA perpendicular to L at A. What is the reason? Radius is perpendicular to the tangent at their point of contact. Theorem 1. So therefore, angle OAC 90 degrees. Reason theorem 1. In the same way, OB perpendicular to M at B. OB is perpendicular to M at B. So therefore, angle OBD is 90 by theorem 1. Angle OBD is 90 by theorem 1. Now add these two. Angle OAC plus OBD is 180. Angle OAC plus OBD is 90. Is 180. That means interior angles on the same side of the transversal are supplementary. Interior angles on the same side of the transversal are supplementary. Okay. So by Euclid's fifth postulate, alternate interior angles, yes, you can do that one, no problem. By Euclid's fifth postulate, or you can take this angle, this angle. This one and this one are alternate interior angles. If the pair of alternate angles are equal, then the lines are parallel. If interior angles on the same side of the transversal are supplementary, then the lines are parallel. Okay, na? So therefore, L parallel to M by Euclid's fifth postulate. Okay, na? Next question. Question number 5. I will explain it to you tomorrow in the class, because we need to apply method of contradiction for that. So I will explain it to you tomorrow in the class. Question number 5. Now question number 6. Length of tangent from a point A at a distance of 5 centimeters from the center of the circle is 4. Find the radius of circle. There is a circle with center O, and there is a point P which lies outside the circle, and PA is the tangent. PA is the tangent. Length of tangent is given 4 centimeters, and the distance between the point and center is given as 5 centimeters. We need to find out the radius. This is the question. Read the question once again. Length of the tangent from a point A at a distance of 5 centimeters from the center. Oh, this is given A, and this is, let it be P. So AP given 4 centimeters and OA given 5 centimeters. Distance of A from center O is 5 centimeters. We need to find out radius, Pythagoras theorem. Okay, na? Pythagoras theorem. And today's last question. Two concentric circles of radii 5 centimeters, 3 centimeters. Find the length of the chord of the larger circle which touches the smaller circle. There are two circles. With same center. Two circles with the same center. They are called concentric circles. Not only two or more circles having same center, they are called concentric circles. Okay. There is a chord AB. AB is the chord of larger circle and tangent to the smaller circle. AB is the chord of larger circle, okay, and it is tangent to the smaller circle at P. Okay, na? And radius of larger circle is given as 5 centimeters, and radius of smaller circle is given as 3 centimeters. Radius of larger circle is given as 5 centimeters. Radius of smaller circle is given as 3 centimeters. And we need to find out the length of the chord. We need to find out length of the chord. How to do it? Anyone? Triangle AOP. In triangle AOP, angle P is 90 degrees, na? In triangle AOP, angle P 90 degrees. So we can find out AP. AP square is equal to OA square minus OP square, 5 square minus 3 square, 25 minus 9, 16. AP will be 4 centimeters. That means this is 4 centimeters. AP got 4 centimeters. Is that right? But we want AB length. We want AB, not AP. We know that radius is perpendicular to the tangent at that point of contact. Here, AB is tangent to the smaller circle at P and it is chord to the larger circle. So we have a property to the chords. Perpendicular from the center to the chord bisects the chord. A perpendicular from the center to the chord bisects the chord. That means AP is equal to PB. OP is perpendicular from the center to the chord AB, so it bisects the chord. That means this is also 4 centimeters. Now length of AB is AP plus PB. That is 4 plus 4, 8 centimeters. Or you can say AB is twice AP. AB is twice AP. Okay, na? So by tomorrow this chapter will be done. Thank you very much for joining the class. You can leave now. धन्यवाद.